You unlock this door with the key of imagination.
This is an object, a collection of properties where each property associates a key to a value. Earlier in the course, we learned that there are 7 primitive data types in JavaScript. Primitives represent a single value like a number or a string, and anything that's not a primitive is an object. In other words, everything interesting that happens in JavaScript is made possible by the object data type. Today we'll take a deep dive into how the JavaScript object works and look at modern syntax and methods we can use to make our code cleaner and more efficient. If you're new here, like and subscribe, and grab all of the videos on this free JavaScript course from Fireship.io. An object is conceptually similar to a dictionary or a map that you might find in other programming languages. The most straightforward way to create an object is to use the literal syntax. Simply define a variable equal to curly braces. Inside the braces, you define properties separated by commas. A property is essentially a key-value pair, where the left side is the property name and the right side is the property value. The property name needs to be a unique value that can be coerced to a string. The value can be anything you want, a primitive, another object, a function, or whatever. Now, even though we define this object as a const variable, we can still set properties on it after it's been created. We can use bracket notation on the object, followed by the name of the property, equal to whatever value we want to set there. Then later in the code, we can read or get that property using the same bracket notation. Now let's imagine that we've walked into an alternate universe, because in JavaScript there is always more than one way to do things. This time we'll create a new object using the constructor syntax. Then we'll set properties on it using dot notation. Dot notation looks a lot cleaner, but your property names will need to be a continuous string that does not start with a number. If you have property names with spaces or that start with numbers, you'll get a syntax error if you try to call them with dot notation. But now we've fallen into yet another alternate universe. This time we'll use a static method on the object class called create. You wouldn't normally use this one for an empty object. It's most useful when you have an existing object and you want it to inherit its properties. Or in other words, use the existing object as a prototype. And this is one of the weirder parts of JavaScript, so let's look at it a little more closely. First, we have a plain JavaScript object called organism. It contains a DNA property of a random number. Then we create a new object with object create, passing the organism as the prototype. When we console log the new object, you'll notice that it's still a blank object, but if we call the DNA property on this object, we get a result back. So it's almost like an invisible property on the new object. That's because it exists on this object's prototype. And we can see this property actually lives on the prototype by calling object getPrototypeOf, which returns the original object we created.
Whatever gave you the idea you were in heaven, Mr. Valentine? This is the other place.
This time we're going to add a property to the object by using object_define_property. It takes the object as its first argument, the name of the key as the second argument, then an object with some options on it known as a descriptor as the third argument. We can use the value option in the descriptor to create an object that is identical to the ones in the previous examples. However, we can now do more advanced things here as well, like define a getter, and that would access the property by calling a function. Now, most casual users of JavaScript won't need to use define property on a regular basis, but it is important to know how it works if you really want to understand the language. In most cases, you'll likely be working with the literal syntax, and it does have a few cool tricks up its sleeve. Let's say we have a couple of variables, and we want to set those variables on an object with the same property names as the variable. In the olden days, we would have to duplicate the property name with the variable. But in modern times, we can simply add the variable to the object literal and it will coerce the variable name to the property name. And we can do a similar thing in reverse with destructuring. This time we want to read an object's properties and set them as variables to use in our local code. In the olden days, we would have to declare a variable and then set its value equal to the object property. Nowadays, we can define multiple variables with a single line of code, and JavaScript will match the variable names to the property names on the object. But what if you want to use this awesome syntax but give your variable a different name? Sometimes you might have to do this to avoid a name collision with an existing variable. Just add a colon after the property name, and then you can name your destructured variable whatever you want. Now, what if you were to try to take this code and then add another property with the same name? This code won't throw an error. Instead, it will overwrite the value on the left with the value on the right. This is important to know because sometimes you might compute properties that you don't know until runtime. Like you might want to create an object based on some data you fetch from a database. You can compute property names by wrapping them in brackets and then place an expression inside, and it will compute that value when the object is created. In this example, we have a function that generates a random number. We can then call that function inside of the brackets to generate the key for this object when the object is created. And you'll notice every time we refresh, we get a different key or name for this property. Now, object properties can also take functions as their value. And when a function lives on an object, it's called a method. You can define a method using the shorthand syntax, where you omit the property name and just define a named function directly in the object literal. And we can also use get and set keywords here to define getters and setters on this object. When you define a method on an object, this refers to this object. However, if you remember from the last video, if you use the arrow function syntax here, it will refer to the global this context. For example, if we convert our makeWeb method into an arrow function, this.web will refer to the global web value as opposed to the internal property on this object. So that's just a weird little thing to get used to in JavaScript. An interesting thing you can do with the this keyword is chain methods together. You'll see the syntax used in different JavaScript libraries, with the most famous example being jQuery. So the question is, how do we chain together methods while keeping a reference to the same object? I kind of already gave you the answer, because remember I said the this keyword refers to the parent object when defined in a method. So if you want to chain method calls together, all you have to do is return this from the method. Now, any method you call will return the reference to the original object. And that provides a good segue into the topic of object references. Previously in the course, we learned the difference between the call stack and the heap. Primitive values are short-lived in most cases in the call stack, while JavaScript objects are kept as references in the heap. Let's take a second to look at the implications of this, because it's very important. Let's look at how things work first with primitives. We'll initialize a variable a, and then set b equal to a. As you would expect, they're both the same value, but they're actually both pointing to their own primitive value. So that means if we change a to a different value, console log them again, you can see a has the new value, but b still has the original value that it got from a. Now let's go ahead and refactor things to make a an object. The big difference here is that b is making a reference to the object created in a. They are both referencing the same object kept in the heap memory, as opposed to copying the value like it did with a primitive. After we update the property, you can see that they both console log the same object, because again, they're both sharing the same reference to it. Now that you know how references work, let's take a look at how we can combine objects together. If you're updating the same object in multiple places, it can be kind of difficult because of the way references work. In many cases, you simply want to clone that object's property into a new object. And one way to achieve that is with object assign. Let's see how it can change the behavior of our previous example. Instead of setting b equal to a, we use object assign to take a brand new object and assign a's properties to it. Now it's important to keep in mind that this only uses the internal enumerable properties of a. You can see exactly which properties will be copied over by using object getOwnPropertyNames, and that will give you an array of all of the property names owned directly by this object. That means any other properties that it inherited higher up in the prototype chain would not be copied over. In addition, if this object were to reference other objects in its properties, those objects would not be recursively deep copied over as well. That means if A was making a reference to other objects, those objects would still be copied over by reference. It wouldn't recursively copy all the values in those nested objects.
That's not fair. That's not fair at all.
If you're looking to clone objects like this, a better alternative might be to use the spread syntax. There are some very minor differences between the two, but they can be used interchangeably in most cases. And the spread syntax just looks a lot nicer when you're combining a lot of objects together. Now, at the very beginning of the video, I defined an object as a collection of key value pairs. And when you have a collection of something, you likely want to loop over it. Looping over an array is easy, but how do we loop over an object? Well, one option is to use a for-in loop. This will loop over all of the enumerable properties in the object as well as its prototypes. And this can be very, very confusing, so most people tend to avoid the for-in loop. A better alternative is to get the keys or values as an array. You can use object.keys or values to do exactly that. Then you can loop over them with a regular for of loop, or you can use one of the built-in array methods like for each. But what if you want to loop over both the keys and the values together? You can get an array of tuples using object.entries. Then you can destructure the key and value variables in the loop. Now, I showed you earlier how to create a new object using the new keyword. But what if you want to customize the way that object is created? You can do that easily in JavaScript by writing a constructor function. By convention, you should always capitalize the name of this function. In this case, we have a zombie function, and it takes an argument of name. We'll take that argument and define it as an internal property on the object. And then we can handle additional setup in this function, like setting a timestamp and also defining some methods. You'll notice that it's the this keyword that allows us to reference internal properties on this object when it's created or instantiated. So this function is actually very similar to a class like you might find in other object-oriented programming languages. When you define a constructor function like this, the way you initialize a new object is to put the new keyword in front of it. Now, in modern JavaScript, we could actually skip the function and just use the class keyword, but the important takeaway here is that we're using a function to instantiate or create a new object. The class keyword is mostly just syntactic sugar for this process. As you can see, JavaScript objects are very flexible and a core building block of the language. I'm going to go ahead and wrap things up there. If this video helped you, please like and subscribe, and make sure to check out the full JavaScript course on Fireship.io. Thanks for watching, and I will talk to you soon.
Beauty is in the eye of the beholder.